Hi, hello everyone. Today we are going to start a new topic that is called as learning curves. This is one of the topic we will be covering in section B of CMA part 1. We will discuss what is learning curve is. Learning curve is nothing but discussing about how a person will learn as he do the same work more and more. Why this is important in costing? We can imagine your employees are new today and they are spending to make one unit, for example, 1 unit of X, they are spending 10 hours. But maybe by end of the year, they have made a lot of units, and by the time they are taking only 88 hours to make one product. So we can say there is learning happened. And this learning happened, we have to consider while we are preparing the budget. Why? Because that is affecting our cost for the total year, right? Here, for example, in the first time, we are spending $10, and at the end, also we are spending $10. But by the end of the year, the cost of making one product is 8 into 10, or we can say $80. But now, at the moment, it is $100. So we cannot come to the conclusion that to make a product it will cost $100. This is wrong. Because as the people are learning more, they are going to improve and their speed is going to increase. Because of that, number of hours required for the complete year is going to reduce. So this we have to consider in our budgeting, because budget should actually, it has to represent the reality in numbers. Okay, so this is what learning curve is. So learning curve are used to describe the fact that people are able to accomplish a repetitive task more quickly when they do more. So this is the concept of learning curve. You can see an example here. If something takes 1 hour to do first time and only 40 minutes to the second time, that means there is a learning happened and there has been a learning curve. Here you can see an example. Here you are making your first unit and you are taking 100 hours to make it. But when you are making the 10th unit, by the time you learned a lot and you are taking only 48 hours. And when you are making the 200th unit, you are taking only 18 hours. So this learning has to be incorporated in our costing. So we have to forecast what learning can happen and how much total cumulative hours needed for the complete period, and our cost is going to change accordingly. So the same numbers, if we plot in a graph, the graph will look like this. And this graph is actually giving an impression that the first unit is taking 100 hours, but 200th unit it is taking only 18 hours. And because of that, the graph is going downwards. The curve is going downwards. So this is the concept of learning curve. So learning curve analysis is used in planning, budgeting and forecasting. We are going to use this learning curve in planning, budgeting and forecasting. Why? Because we have to get exact cost of labor for the complete year. We know that now we are spending 100 hours, but by the end of the year, maybe we'll spend 50 hours only to make one unit. So this learning also, if we consider in our budgeting, we can at least approximately reach what is the number of hours completely needed for the full year. And this learning is normally expressed in percentage. For example, if we say 90% learning is happening or learning curve is 90%, that means when an employee is doubling his production, or every time cumulative quantity is doubled, there is 10% efficiency gained. For example, if you make one unit, he is taking 100 hours, and when this is doubled, the production is doubled, it became 2, and he's taking only 90 hours. So when it is doubling, your cumulative average production time per unit is actually reducing. So this is what we are going to cover in this chapter. And now, I believe you understood the importance of learning and how that is related to our costing, and this costing will end up in preparing a more accurate budget for an year. And these learnings, we have like 2 types of calculation in this. That's what we call it as, there will be 2 models in this learning curve. We have different models. So one model is incremental unit time learning model. So what is this is telling, the last unit when you produce, the number of hours you spend on that is going to decrease. For example, you made 1 unit that is for 100 hours. Second unit you spend only 80 hours. Third unit you spend only 64 hours. So the last unit, for this unit you spend only 64 hours. So this is normally used in marginal analysis. What is marginal analysis? What is the cost of the last unit? Maybe you have to estimate this also sometimes. So that is what we will be covering in incremental unit time learning model. So how you will calculate the incremental unit time learning? You will take the initial time, for example 100 hours, and when that is doubling, you will multiply that with a percentage of learning, for example 8. So we can say now 1 doubling happened and you can make this particular product in 80 hours. Again, you are making a product, you will make that in 64 hours. So how you are getting it? You are taking the initial time and multiplying that with the learning again and again based on how many times it is going to double. Okay, so here another model is cumulative average time learning model. This is based on the assumption that cumulative average time required per unit declines as a constant rate each time the cumulative quantity of unit produces doubles. Again, when the quantity is doubling, the average time required for each unit or per unit is going to reduce. Okay, we will see an example of this model in the coming slide. So first we will see the incremental unit time learning model. Before that there is a comparison of both the method. We can see here incremental unit time learning model. This is actually focusing on the time required for each unit. For third unit or for eighth unit, how much time required. It is not considering the time required from first to eighth unit. It is only considering the time for the eighth unit, and normally this is used for marginal costing. Marginal costing is the concept of calculating the cost of the last unit what we produced. But cumulative average time learning model, this is used when you are focusing on average time per unit. You want to know what is the average cost of making a product. You are not looking at the last unit only. You are considering from beginning to end and what's the average time required to make one unit. And this normally applies when you have to find out what's the average variable cost per unit. So you are not looking at the last unit in cumulative average learning model. So we can see an example of incremental unit time learning model here. Here learning curve is 80%. So the percentage of the learning curve tells us how much improvement takes place every time production is doubling. The doubling is important. Okay, and the lower the percentage, greater the amount of learning. If it is 90%, that means you are achieving only 10% efficiency. If it is 80% learning, that means you are achieving 20% efficiency when the production is doubling. So you can see an example here. The first unit you are taking 1000 hours, and here the learning curve is 80%. For the second unit, you are taking only 800 hours. So now you will have another doubling. From second, it will go to fourth. So again, you will take 800 multiplied with 0.8. It is taking only 640 hours. Like that, it will go. And you can see here, 32nd unit, you are taking only 328 hours. So here we are considering what is the hours required for 32nd unit. We are not considering what is the cost from first to 32nd unit. So this is the purpose of incremental unit time learning model. The calculation of incremental unit time learning model is easy. You will take the first unit, for example, then how many doublings are going to happen? If you are making 8 units, that means you have 1, 2, 4, then 8, right? So from 1, you are having 1, 2, 3 doublings. Okay, so you will multiply this with 0.8, again 0.8, again 0.8. So you will get the incremental unit time required for the 8th unit. Okay, so you can see here, you are taking the initial, you are multiplying 3 times with 0.8, and you can see 8th unit is being produced in 512 hours, and it is comparatively easy when you are talking about the next method, which is cumulative average time learning model. And you can see here, when this 80% learning curve is plotted in a graph, it will look like this, and from this you can understand the learning is happening, and the time required for each unit is reducing as the production is doubling. Now we will look at the second method, which is cumulative average time learning model. So here our focus is on calculating the average time needed per unit. It is not just considering the last unit, it is considering the units from beginning to end and calculating the average based on that. Okay, so cumulative average time learning model assumes a constant rate of declining is happening in the hours for the average for the unit you produced. Each time the quantity of produced is doubling. So average time is reducing when you produce more and more unit. And this we will be using to calculate 3 things. One is to calculate average time per unit. As we discussed, we will calculate the total hours required, and based on that we can calculate average time per unit. To calculate the average time per unit, obviously you have to calculate the total time required for the entire quantity. That also you can calculate. Then the third one is the total production time required for a certain block of units. So this we will discuss in an example in the coming slides. What is a block of units? Okay. So here we have an example of cumulative learning model. You can see here, when you are making first unit in this company is considering actually a learning curve. And you have another company here, they are not considering whether a learning curve is occurring or not. But this company is considering there is a learning happening in the factory. So first unit you are making in 100 hours. Second unit, we will assume that the first unit doubled, it became second unit. So how you will calculate the hours? You will multiply that with 2, right? 100 hours, and when it is doubled, that means you will multiply with 2, it became 200. So it is 200 hours. You will multiply the 200 hours with 80% learning curve. So you will see that the total accumulated or cumulative hours required for second unit is 160 hours. And in this example, we will not consider third unit because we are always focusing on doubling. So now second will double to fourth. So we will take this 160, this was the total hours required for the second unit, and when it is doubling, again you will multiply 160 with 2. So you will have 320 hours here. That again you will multiply with 80%. So you can see now the total hours required is 256 hours. So we will skip 5th unit, 6th unit and 7th unit because we are focusing on doubling only. So now 4 doubled to 8. So we will take this 256, multiply that with 2. So you will get again 512 hours. You will multiply that with 80%. So total hours required now is 409.6 hours when you make 8 units. So this is the logic how the formula is deriving. So what we can do is, we can generalize this formula by taking this 100 hours, that is what our initial hours is. Then you can see everywhere you are multiplying this with 2 multiplied with 0.8, right? So 3 times from 100 hours, it is getting multiplied with 2 multiplied with 0.8, again 2 multiplied with 0.8, or we can say 3 times the 100 hours is getting multiplied. Or we can say 100 multiplied with 2.8 raised to 3. 3 times we are getting it multiplied. So the shortcut or the formula for calculating the cumulative learning curve is like this. You will take the initial hours, then you will multiply that with 2 with the learning curve percentage. And you will have how many times or how many doublings are happening. That is what that 3 indicates. So now you can see 409.6 hours they will be taking to make 8 units. And imagine their labor cost is $10 per hour. So how much they are going to have total cost for the year or for month? It is 4,096. This is for the company. They are considering there is a learning happening in the factory. But you have another company, they don't consider this learning. That means they will consider first unit they are taking 100 hours, second unit also 100 hours. So 8 unit for them to make, it will take 800 hours for them. And again they will take per hour cost is $10, and 800 into $10 here, that company is getting $8,000 cost, whereas this company is only $4,096. So you can understand the importance of learning curve from this example. So how much difference they are getting when they are considering the learning into their calculation. So this is an example of cumulative learning curve. So you can see here estimated time required for all units. You can generalize the formula like this. The required time for the first unit, then you will multiply that with the learning curve and 2. Then you will have raised to n. This is the number of doublings happening. So how many doublings happening here? This is the learning curve. Just multiply that with 2. And how we derive this formula, that is what explained in the previous slide. So if you know the total number of hours now, if you know the total number of hours here, 409.6, you can calculate the average time per unit, right? It is going to be total hours divided by how many units produced. So here we can see it is 52.2 hours only, whereas in this case their average hours are 100. So the difference is almost 48 or 47.8 is the difference. Okay, so estimated cost, estimated cumulative average time per unit is going to be 52.2 hours in this case. So this is what we are going to apply in our calculation. So we have learned two models. One is incremental model, other one is cumulative model. So even though we are taking same percentage of learning, both models are going to give you different result. So that we have to understand. So in your question, they will precisely they will mention which model you are going to use. So now we will see some examples. Here we can see estimated total time required for all units produced. This is what we are going to calculate. So here we can see the example. The production of the first unit of product A requires 10,000 direct labor hours, and the learning is 80%, and they are making 8 units. So what will be the total hours required to make 8 units? So we can apply the formula here. We will take the first or the initial hours required, multiply that with 2 into 0.8, or 2 multiplied with 0.8, or we can say 1.6 you will multiply, and raise to 3, because 3 doublings are happening. So the answer is 40,960. How we got that? We are taking the initial number of hours, multiplying that with 3 times of this cumulative learning. So multiply that with 2 multiplied by 0.8, again 2 multiplied with 0.8, again 2 multiplied with 0.8, or we can say 1.6, 1.6, 1.6 3 times. Or you can calculate like this: 10,000 multiplied with 1.6 raised to 3. So that way you will get this answer, which is 40,960. This is the correct answer. So this is how we will calculate the total hours required based on cumulative average method. This is another use of learning curve model, which is cumulative learning curve model. You can find out how much time required for a specific block of units. So what does that mean? Imagine I made 80 units and you took 120 hours for this. Okay, this is your first batch of production. You made 80 units and you took 120 hours. Now you need to make 240 units more. Okay, or you have to make a bid for another 240 units. So how many hours you will consider only for these 240 units? Or this is what we call it as a block. So for that 240 units, what will be the cost? So that we have to consider. Okay, so we will go and see the example here. Time required for a specific block of units. Same example I have given. 80 units when you produced, you spent 120 hours. And now you need another 240 units to be produced. And the learning curve is 80%. So what will be the total cost of making this extra 220 additional unit? And now this is what we consider as a specific block. Now we need to know how much we are going to cost to make these 240 units. We need to get this information so that we can make a competitive bid for our customer. So how we will calculate the cost of the last 240 units? We can do the calculation. So we have 4 options here. So we have to find out which one is that. Okay, so here I will just explain this. For example, when you make 80 units and 240 units more you have to make, right? So that means total you have to make 320. So what is the doubling happening here? From 80 it will become 160, that's the first doubling. Then from that it will become 320, that's the second doubling, right? So we can calculate the total hours required for 320 units. And from that, we will minus the hours required for the first 80 units. Okay, so first we will calculate 120 hours multiplied that with 1.6. How many doubling? 80 to 160, 160 to 240, 2 doubling. Okay, and you will get here 307 hours you will get. That's the total hours required. To make how many units? To make 320 units. But we don't need the cost of or the hours of 320 units. We just need the hours of 240 units. So what we can do is, we calculated the total hours required for 320 units, and we know that first 80 units we spend 120 hours. So from the total hours, we will minus this 120 and you will get your correct answer, which is 187.2. Okay, so this is going to be the answer, and the answer is explained in this slide. So I hope you understand this. So this is an example of calculating the time required for a specific block of units. Now this is talking about the limits of learning curve percentages. Like, what are the limits of learning curve percentage? The first one is the learning always has to be less than 100%, and the learning curve must be greater than 50%. It should be always greater than 50%, and it has to be less than 100%. So imagine if the learning is less than 50%. In this example, learning is 40% and 3 doublings are happening. And we will apply same formula. Imagine first unit you spend 100 hours. So you will multiply that 3 times with 2 into 0.4, 0.8, 0.8, 0.8. So what you are getting is 51.2, which is impossible, right? First unit took 100 hours. Now 3 units or 3 doublings is taking only 51.2 hours. This is completely wrong, right? Because it is less than 50%. And if it is 50%, for example, then what will happen? We can again check same example here. Here learning is 0.5. So 2 multiplied by 0.5 is 1. Again 1. Again 1. So 100 into 1 into 1 into 1, it will become 100 only. Okay, so it is again telling that you produced your first unit within 100 hours, and also 200, 400 and 800 units also in 100 hours. That is also wrong. So here the limitations of learning curve is that the learning has to be greater than 50%, and always it is less than 100%. Otherwise, it will give wrong answers. And these are the benefits of learning curve. Development of production plans and labor requirements. So you can plan well for your production plans because you know how many hours we are going to have for the complete period, and it is considered as a management control. Recognizing that higher costs will incur in the early phase of product life cycle allows effective evaluation of managers. Maybe you have a manager who is working in the beginning stages of production, and during his time the cost is going to be high because the learning have not been happened. But later maybe learning will happen, and that time cost is going to be less, but based on that you cannot evaluate the managers because we have to consider the learning aspect that happened in calculating the total cost. And you can consider development of standard cost. You have to prepare a standard cost. What is a standard cost? We have to establish a per unit cost for a unit you are making in the organization. So when you are making that, it has to be as accurate as possible. So if we consider the learning also in preparing your standard cost, then that is going to be as accurate or more accurate than without considering the learning. And you can use it for life cycle costing. We studied life cycle costing in section D. This is like the cost that required for a product from worm to tomb. That's what we explained. From research and development to the production, to the distribution, to the customer support, all this time, how much cost you are spending for this product. So when you are doing this life cycle costing, you have to consider the cost that will change in future because of the learning that is going to happen in the organization. In cost volume profit analysis, you will be using learning curve also. Cost volume profit analysis is a topic we will be learning in part 2 of CMA. There also we need to use learning curve, because cost volume profit is going to consider the total variable cost required for a product. So when you are calculating the total variable cost, you have to consider the material and labor and overheads. So labor cost, if you want to get accurate as possible, you have to incorporate learning also into it. And even in capital budgeting, you can use learning curve. So what is capital budgeting? Maybe you are going to make a long-term investment. You are going to buy an equipment, and that is going to serve you for 20 years. And you have to do a feasibility study now. So you are buying this machine, and how much benefit you are going to get. So what will be the sales you are going to make, and what will be the cost of that? That we have to understand, right? So for understanding the cost, and since it is for a long term, we have to consider the decline in cost that may happen because of the learnings happening in the organization. So these are all benefits of learning curve. And also make or buy decision. Sometimes you may decide, there is some component that we are making always inside the factory. Why don't we buy it from outside, so that we can empty some space, we can use it for something else. But again, we have to consider which is beneficial, making or buying. So for making, we have to consider all the cost required for making the product internally. So in that, you have to also consider the labor cost. So labor cost, when you are considering, you have to consider the learning also into it. Then only you will get the accurate costing for labor. And these are the limitations of learning curve. The learning curve analysis is appropriate only for labor-intensive operations. When your operations are mostly based on machineries, then there is no point in calculating the learning which is going to happen, because machines are not going to learn. The individuals or human beings are going to learn. Machines are going to do the work mechanically. So learning curve is mostly used in labor-intensive situations. And another drawback is that learning curve is assumed to be constant. We are always considering there is an 80% learning. Whether it is first unit or second unit or fourth unit or eighth unit, whatever units, we are considering there is constant learning happening, which is 80% or 90%. That is also not realistic. And an observed change in productivity might actually be associated with factors other than learning. So we can say maybe there is no learning happening, but a change in productivity can be associated with other factors. Maybe we can say you are mixing your labors more efficiently, and because of that your production is improving, or the speed of the production is improving. That is not because of learning, but you are doing this different mix of labors. Like you will have skilled labors, unskilled labors. Maybe you will try a combination of one skilled labor for 3 unskilled labor, something like that. That way also you can improve the hours required for production but not necessarily this is because of the learning happened. Okay, so that's it about learning curve. Thank you for being with me, and we will see you in the next presentation, which is going to be a part of forecasting again, that is regression analysis. Thanks a lot. Thank you for being with me. Bye bye.